Welcome to Chapter 15, 15.3, Calculating Flow Rates. So, to calculate flow rates in milliliters per hour, once again, please note the units. We're going to be using milliliters per hour. These are the units we need. Identify the following. V, the volume, is expressed in milliliters. If it is ever expressed in any other unit, you need to convert it to milliliters to use the formula that we're going to be using. T time must be expressed in hours. Once again, convert the units when necessary. And F, flow rate, will be rounded to the nearest whole number. And we're going to use the formula. Flow rate equals volume divided by time to determine the flow rate in milliliters per hour. So, for example 1, find the flow rate using the formula method, which is right here. So, ordered is 500 milligrams ampicillin in 100 milliliters of normal saline to infuse over 30 minutes. And we're asked to solve this using the formula method. What we need is the volume and the time. And when I'm reading this, first thing that I do notice is that my time, T, is in minutes. Okay, this is not the correct unit, so I know I'm going to have to change that to hours, or at least to what it is in hours. And then the volume that we have is 100, which is indeed in the correct units, milliliters. So we do not need to convert that. So we have V is 100 milliliters, which is great. Now we need to find out what T is. So let's go ahead and first convert minutes to hours. Alright, so the conversion factor we're going to use is how many minutes in an hour. So what we know is that in 1 hour we have 60 minutes. I'm just going to set up a proportion for this. You don't necessarily need to if you can just do this in your head. So 30 minutes. We can go ahead and cross multiply. Oop, forgot to mention X is number of minutes. Sorry, number of hours. Alrighty, let's keep going. So X times 60 minutes is going to equal 30 minutes times 1 hour. Let's go ahead and cancel the minute units. And why not divide by 60 at the same time? Then we get X equals 30 divided by 60 hours. So X is going to end up equaling 0.5 hours. Okay, so now we have my time is 0.5 hours. So finally my time is in the correct units. Now we can go ahead and use the formula to solve. Let me go ahead and partition my workspace here. Second, use formula to find F. And here is our given information. Ooh, that was kind of nasty. Actually, you know what? Let me rewrite that just because I squished it in a little too much there. Don't want my work to be that messy. Want to make sure you can read it. So we know V, volume, was 100 milliliters. T is 30, oh, it was 30 minutes, but we needed to get it in the right units, 0.5 hours. So we're going to use our formula, which is right up here. Flow rate is volume divided by time, which our volume is 100 milliliters, and our time is 0.5 hours. And we can go ahead and simplify that, and we get 200 milliliters per hour. So then our flow rate is 200 milliliters per hour. I'll write that in a sentence. Alright, so if 100 milliliters infuses in half an hour, then it would make sense for 200 milliliters to be infused in 1 hour. Alright. Let's look at the next example. So example 2. Find the flow rate using the formula method. So we have ordered 500 milliliters of dextrose, 5%, half normal saline, over 3 hours. Okay. As always, let's check the units. We need our volume to be in milliliters. Let's see, is our volume in milliliters? Yes, it is. Awesome. Don't need to change that. And let's check our time. Is it in hours? 3 hours. Yep. We're good. So we don't have to change any of the units. It's all good and set up for our formula. Oops, not V. F equals V divided by T. So the volume is 500 milliliters divided by the time, which is 3 hours. And we get that F, the flow rate, is going to be equal to, plugging that into our calculator, is about 166.7 milliliters per hour. But once again, we want to round up to the nearest whole number per the instructions. So that's going to be F equals 167 milliliters per hour. Once again, we need to round to a whole number. And let's see, does this make sense? Well, if 500 milliliters is divided by 3 hours, it equals 166.7, rounded to 167 milliliters per hour. Yeah, makes sense. So our answer is the flow rate is 167 milliliters per hour, period. And box our answer. Awesome. So now let's take a look at the next concept. So this is converting the flow rate in milliliters per hour. Capital F stands for flow rate, and then we're converting this to drops per minute, which is lowercase f. So a good way to memorize that is that the minutes is smaller than an hour, so we would use a lowercase f because minutes are smaller than an hour, and capital F was in terms of hours. So here's the formula we are given for converting from milliliters per hour to drops per minute. Little lowercase f equals capital F times C, which we'll go over in a second, divided by 60. Where F is the flow rate in milliliters per hour, we know this one. C is a calibration factor of tubing, GTT per milliliter. That is a new one. And 60 is the number of minutes in 1 hour. All right, makes sense. Then we're going to round the answer to the nearest whole number like we did previously. Now let's take a look at our first problem. Find the flow rate in drops per minute. So we want to find lowercase f. That is equal to 75 milliliters per hour. Okay, so that is my original flow rate. So capital F. When we're using 20 GTT per milliliter macro drip tubing. This is new, and this is our calibration. Alright, well, everything is in the correct units. We have milliliters per hour and GTT per milliliter. So let's go ahead and use our formula. So, drops per minute is going to equal, I would just like to write out the formula in the beginning. Now let's go ahead and fill this in. F was 75 milliliters per hour times 20 milliliters divided by 60. All right. And that is 60, and this is in terms of minutes per hour. So let me write this out a little more like what it's actually supposed to look like to help with canceling some of our units. Got all those fractions going on. Alright, let's see what we can cancel out. So from the top and bottom of these two fractions, we can cancel the milliliters. And then from the top and bottom of this fraction and this fraction, we can cancel the hours. So it's a complex fraction. Alright, and all of the denominators have now canceled out, so we can go back to a regular fraction. We got rid of the complex fraction there. Alright, let's see. For simplifying, I'm going to go ahead and just cancel those zeros for now. Let's rewrite that. So it's going to be 75. Well, 75 times 2 will be 150. All over 6. And then, let's see, that's going to simplify out to 25. Ooh, I forgot the minutes there. And there we go. We can just drop down that F there. And there we have it. So what is the answer? The flow rate, which we're trying to find. So the flow rate is 25 per minute, period. So let's keep going. All right, now, so to adjust the flow rate, first, check the guidelines at your facility to determine whether you are allowed to adjust the flow rate in general, so make sure you check before doing something like that. So, moving on. To recalculate the infusion rate in GTT per minute, or lowercase f, use the volume remaining in the IV and the time remaining in the order in minutes. Use the following formula. That should be a capital U. All right, another formula. Actually, let me do blue. The other ones are in other colors. Let's do blue. Where C is the calibration factor of tubing, we already know those units. V is the volume remaining in the IV, once again in milliliters. T is the time remaining from the original order. All right, in minutes this time, interestingly. So to recalculate the infusion rate in milliliters per hour, so to go back to capital F from lowercase f, we're going to use the formula remaining in the IV solution. Now that should not be the type of plant. When you thought you did such a good job editing your notes and you see an error. And the time and hours remaining for the order, use the following formula. F equals V over T. Volume over time. All right, so let's look at example 4. Let me actually leave the formula there. Okay. Calculate the adjustment in milliliters per hour using the formula method. The original order was 1,500 milliliters normal saline over 12 hours. After 4 hours, 1,100 milliliters remain in the bag. So let's look at the information that we do have. Well, we know the volume, 1,500 milliliters, which is in the correct units. And then we know the time. Well, actually, we have to figure that out. The original time was 12 hours, and 4 hours has gone by. So to find out the time now, let's see, 12 hours minus 4 hours is going to be 8 hours. All right, so my time is going to be 8 hours. And then let's see. Well, we have all of the information we need for the formula. So we're using F equals V over T. So let's go ahead and plug this in. F equals 1,500 milliliters over 8 hours, which can calculate out to be 137.5 milliliters per hour. And we need to round out to to the nearest whole number, 138 milliliters per hour. So, depending on the facility that you're working at, they sometimes have policies about how much you can adjust a flow rate. Some policies say you cannot adjust it more than 20 milliliters per hour. So you need to check that with what your calculation adjusts out to. And so it does depend on your facility, so you want to make sure you check on that before you go ahead and adjust things. With that being said, we can go ahead and write our sentence. The flow rate, the new flow rate. Let me go ahead and erase that. The new flow rate is 138 milliliters per hour. Once again, you'd want to check to make sure that the flow rate you're changing it to is allowed by your facility. Let's go ahead and look at example 5. Now we're told to calculate the adjustment in GTT per minutes using the formula method. So the formula for that is F equals C times V over T. Let me go ahead and write that down. So that is F equals C times V over T. So the first thing we want to do is gather all the information that we have and convert if necessary. So the volume is 1,200 milliliters. This is after, by the way. And the time is going to be, well, the original time we have, let me do that in green actually. Original time we had was 12 hours, and then we're looking at this after 3 hours. So 12 hours minus 3 hours is going to give me 9 hours remaining. That is 9 hours. And actually, for this problem, we need the time in minutes. So we're going to have to convert this one. Okay, so we're going to do that. Let me just go ahead and put down what else we know. We know that C is 20 GTT per milliliters. Alright, so the first step we're going to do is convert from hours to minutes for this problem. So we have 9 hours. We don't know how many minutes. Going to go ahead and use the conversion factor of 60 minutes in 1 hour. Okay, we can go ahead and cross multiply to solve, or you could do this in your head. So 60 times 9 minutes and hours. Go ahead and cancel the hour units. Oops, wrong pen. And we are left with x equals 540 minutes. And there we go, which is 540 minutes. Now it is in the correct unit there. Okay, so everything we need is in the right units. Let's go ahead and work on the next step. So second, we're going to do calculate. So our formula, lowercase f, C times V over T, which is going to equal, so C is 20 GTT in 1 milliliter times, and the volume is 1,200 milliliters all over. The time is, remember we're using the minutes here. For this formula, we need it in minutes. When we do that, let's see, does anything cancel? Well, we actually have a bunch of milliliters here. We can just go ahead and cancel these two with each other. Why not? F equals 200 GTT times 1,200 all over 540 milliliters. Let's just simplify some of the zeros out for fun here. Why not? Boom, boom. And then we can calculate that out. So that was going to be, let me just clean this up. So 20 times 120 all over 54 milliliters. Plugging that into your calculator, you get 44.4 GTT per minute. And we need to round to the nearest whole number. So that's going to be F equals 44 GTT per minute, which is the adjusted flow rate. Oops, rate, not freight. Alright, so the sentence for our answer is the adjusted flow rate is 44 GTT per minute. And once again, you'd want to make sure with your facility about what you're allowed to adjust to. Okay. And that is it for this section. Please email me if you have any questions or any trouble with the homework.